Welcome to Research Renaissance, presented by the Karen Toffler Charitable Trust. Embark on a journey into the forefront of cutting-edge brain science as we feature insightful discussions with a diverse array of guests, from early career researchers pioneering groundbreaking science to influential voices in investment communities, policymaking, and research institutions. Together, we delve into neurological diseases, their causes, treatments, and the quest for cures. Join us in advancing our understanding of the brain and addressing its ailments. Welcome to Research Renaissance. I'm Deborah Westphal, your host and guide through the fascinating future of the brain. Joining me today is Dr. Melissa Flagg. Melissa is an advisor for the Andrew W. Marshall Foundation. She is also a fellow at the Acquisition Innovation Research Center, and previously she served as the Deputy Assistant Secretary of Defense for Research. Today we will be discussing the future of research and development. Welcome, Melissa.
Thank you.
Melissa, your career is a pretty amazing career, and you've had, the journey across government, academia, the private sector. This really gives you kind of a unique perspective into the U.S. research and development ecosystem. Can we just start with just defining what that ecosystem is and how kind of complex it is?
Yeah, I actually love this question because I think in the United States, it is a particularly interesting ecosystem. Often, I think wherever you sit gives you a perspective that that place is the central place where research happens, but it's such a massive, dynamic, and highly decentralized system. So we tend to think about academia as the primary place where research gets done. It certainly is a powerhouse, especially for kind of longer range research, the fundamental science that underpins a lot of application down the road. But even in academia, you've got very different types of work going on, even in a single large institution. So obviously, there's a lot of money that comes from the federal government. We've got so many agencies in the U.S. government that are funding science, the National Institutes of Health, the Department of Energy, the National Science Foundation, the Department of Defense, but the list goes on, right? USDA, EPA, it goes on and on. And that is a large contribution to the funding that goes on in research and academia. But academics are also getting money from foundations, obviously, from the philanthropic sector, and also from the commercial sector. So there's a tremendous amount of funding that goes into these academic research settings that is not just federal funding. Additionally, when you look at the government, they're not only funders, right? They also perform research. So there's a tremendous number of laboratories across the Department of Defense, obviously the national laboratories through the Department of Energy that most people have heard of, but also NIH has laboratories and many other organizations have their own laboratories. That in addition to that, there are these federally funded research and development centers, or FFRDCs, university affiliated research centers that have like special relationships with the government. So they negotiate these large contracts and they can take work and do work specifically for the government and not compete with industry. But then I think what's been so interesting in the US is if you look back into history and sort of post-World War II in the 1960s and the 1970s, the US federal government was so significant. It was the 800-pound gorilla in the room, right? The United States was almost 70% of global R&D back in the late 60s. And the US federal government was almost 70% of that R&D, right? So like the federal government of the United States, and of that, I think 30% of that was Department of Defense. So like the US federal government had so much control and impact on our ecosystem in the sort of 60s and 70s that has held over sort of culturally is how we think. What you see now, however, is that the federal government funds about 20% of the research in the United States, and a huge portion, the rest of that 80%, is industry with philanthropy and academic endowments and other sort of states and some cats and dogs in there coming in to fill up maybe another sort of 12% of that or something. So I think there's this idea that it's academia and the federal government, and they make up this ecosystem, and that the federal government pays and academia produces. But it's not quite so straightforward. Almost every single sector is both funding and performing research in some ways. And they all have different rules. They all have different priorities, which creates a very rich system in that probably no matter who you are, if you can find your tribe, there's someone who's interested in what you're doing. On the other hand, you really have to look to, and you really have to work to meet your people, right? Because there's not a Rolodex or like a single list of everyone who might be interested in what you're doing and how you're doing it. And I think that can be a lot of work, and it's very hard. And in the US, that is, I think, quite unique in how sort of decentralized and dynamic that ecosystem is.
How big is it? I mean, it's got to be trillions of dollars when you just round that all up.
I mean, it's not trillions annually. Now, it is globally. The estimates are that we're about, I think we're probably up at around 2.5 trillion or something, sort of globally. We could be above that now. I'd say that of that, let's just say 2.5 trillion, about 50% of that comes from the US and China. The US and China both make up kind of about roughly 25% each, and then the rest of the world makes up the other 50%, which is also why I get frustrated when I hear people talk about technology as a US China bilateral issue, or like we've carved the world up into two. That sort of smacks of people wanting to go back to the Cold War, in my opinion, because we really do need to be conscious that even though there are not a lot of other actors in the world that are holistically as large as we are and span sort of the full range of capabilities that we focus on, there are many nations that are punching far above their weight in specific areas where they've decided to maintain focus. Certainly countries like Japan, Germany, France, the UK, India, there are so many countries out there that are punching far above their weight and that we don't talk about nearly as much. And so I think it is really important to realize that it's a huge ecosystem, but it's not just the US and China that are playing. And additionally, in the US, I think that the full federal government R&D bucket, which is more than just basic science, is up somewhere around maybe 150 to 200 billion per year. Huge amount of money. That's a lot of money. Maybe 150 more, probably I think more in the range of about 150 billion. But the commercial sector is pouring so much more than that in, right? So they're pouring in hundreds and hundreds of billions of dollars. Now, they're pouring it into research that tends to be very applied. It tends to be very product oriented. It's often not transparent. It's often hard for others to leverage or access. So while it is critical and valuable and something that I have a lot of support for as part of the ecosystem in the United States and something that the nation can leverage and that supports economic growth, it is not really producing the same or playing the same role in the system that more basic research is intended to play.
Yeah, and I think there's a lot of people that don't understand what that, when you say basic research and then when you say development and how development is different. Can you go through kind of that pipeline, if you would, of research in a way that people can understand? Because it's quite a extensive kind of process to get it to a product.
So I will talk about this. I will just say that no system is perfect. And I think that often people on both sides of this discussion get quite defensive because they are very passionate about what they do. Scientists and engineers, and also people making money, all tend to be very passionate about doing those things. And so I want to say that I'm going to describe a little bit about the ideal version of this system. But then I do think we owe it to ourselves to also have a real understanding of where the system breaks down. Because we are in a moment that's very uncertain, where a lot of this is being challenged. And some of those challenges are things that the community would do well to integrate and understand and improve on. So I think it's an important journey, albeit quite uncomfortable at the moment, I think. Um, so the sort of concept of basic research in the United States really goes back to a document that was signed in 1945 by Vannevar Bush, who wrote this document called Science, the Endless Frontier. And I highly recommend it. You can find it as a PDF online. It's on the National Science Foundation archive. And it's very short. It's like 45 pages. It's written in plain English. And it gives you this incredible view of what it was like to be a leader at a moment where we'd come out of World War II and the entire world had changed. It was a huge moment of transition. So we can see the Cold War sort of looming on the horizon, but we're not quite there yet. But we also have this wave of people coming home from the war, and we have to have jobs for them. And the United States is now sitting in a different place globally. We're playing a different role. Almost all of the leaders in science and technology had been devastated in this war. Germany, when you got a PhD in chemistry in the late 1800s at Harvard in the United States, you had to learn German because you had to be able to read the Beilstein, which is where all of the sort of chemistry was, because they were the leaders. So it's important to realize that leadership changes, and it hasn't always been static historically, and it most certainly will not be static going forward. So in this moment, Vannevar Bush, who both started Raytheon, right? So he's an engineer who was fully part of the war effort and was all about solving problems, and he liked to make a little bit of money. He was also a professor at MIT, and he saw that the Europeans had a lot more space in their research ecosystem for what he would call patience, right? So that we needed places where research could happen, that could happen at a pace that wasn't necessarily going to be turning out a result every quarter for the shareholders, right? In sort of the parlance of today. And he felt like the universities in the United States, our academic institutions, were not being leveraged as much as they could be, and that this was a gap in the system that the US federal government could provide this sort of basic research funding to universities as a way to build this capability up. Now, this is important in that moment because we know we can't depend on anyone else now. We are now in a position of global leadership that we did not hold before World War I starts. We also did, in fact, get a lot of help from our European allies in sort of putting a lot of the technology together that we now sort of talk about how we used it to win the war. Yes, but we most certainly didn't do it alone. Vannevar Bush knows, and Roosevelt at the time knows, we absolutely can't go into another war without having some of this intellectual capability at home because we don't have anyone else to turn to in this moment. So we see it as an opportunity. They create the National Science Foundation. They also create the Office of Naval Research Global. Interestingly, it precedes the National Science Foundation by a year. That opens up in Europe. That's really about getting people out there to understand the technology development that's happening around the world. And Office of Naval Research comes online shortly after. And then we really don't do a lot with this structure until the Cold War begins to ramp up. That we already have the structure. We're able to pour some funding into some of these mechanisms and they produce incredible results, right? We wouldn't have the aerospace industry that we have in this country. We wouldn't have a Silicon Valley if it weren't for a lot of what the government does in this time period. So that concept of basic science is really important. In the 80s, we see some executive orders that come out that talk about how we need to protect this research from having any external kind of constraints placed on it. So this creates the system we have today. Now, some of the criticisms that you get of this system is that people do basic research, they publish it, and that's the end. Many researchers who really want to go on to the next hard problem, which is great. It's what they're good at and it's what we want them to do. But the challenge is most of this stuff is written in technical language, in technical journals, behind paywalls and behind jargon that no normal human being can understand. We also have a replication crisis in science, not just in the US, where it's very hard once people get so specialized for reviewers to know, could I replicate this or not? Right? So we kind of have to trust that the researchers are telling the truth, that the data is really the data, that they really did what they said they did, and that it can be replicated. So we have this tremendous amount of basic science that's published in all of these journals. And this is growing exponentially, right? It's like we're doubling the scientific literature like every 10 years. So at this point, once you're producing, because now I think we produce upwards of 1.5 million articles in a year, how can anyone possibly keep up with the scientific literature? So it does become frustrating to people who have been told science will solve your problems, that so many starts to those solutions exist, but there are so few avenues to channel that knowledge into actual concrete solutions for communities. We do tend to have lots of ways to channel research into startups, things that can make money. So there are avenues like CIBERS and I-Core and incubators and all of these accelerators that try to pull university research out and let people spin it off and make money on it. And there are great ways to recognize the prestige of being intellectually at the top of your field. So this sort of profit and prestige motives exist, but the public good, there's no avenue to take science to application from the incredible ideas and research that is published in the literature and turn it into solutions that won't make someone rich. So this is a criticism that the structure has. I would call it more of a gap and an opportunity, and one that has grown over time, and that there are lots of ways that we could tackle it. But I do think it drives some of the criticisms around basic science almost more than a lack of understanding for what basic science is.
So you talk about the gap. I think you just published an article actually for the Andrew W. Marshall Foundation, and the title was "The New Gap in America's R&D Funding Landscape." Is this what you're talking about? What can you discuss some of the observations and what is this gap and what are the implications?
Yeah, I mean, to me, I think the gap is that over time, as we move towards this federal funding, this model where the federal government was so important in funding research at universities, specifically in this case for basic research, that they became the arbiters of the questions that were prioritized. So they put a call out. We're interested in artificial intelligence and trust or something, right? And then all the academics write their proposals, and try to get access to that funding. And then the program manager, usually a single individual, right, will get all of those proposals. They'll create a review team of some kind. Everyone will review the proposals and they'll choose which ones to fund. So the challenge is that even if everything is perfect in the review process, you've still determined what the most important question is without any co-creation with the community of people that pay the taxes that fund you. There can be a moment where expertise and democracy, there's tension there, right? That expertise is necessary in many cases, but it requires trust from a population, right? And if the expertise goes too far away from the democratic sort of desires of the population, then that's problematic. So I would say that if you really went out and you asked folks at the community level what their big problems were, science has actually made a lot of progress that can be applied to many of the problems we have today, but there's no mechanism to work on the specific problem, the specific bacteria that's creating issues in the water, or the specific, challenge that's creating a blight in the crops in that area, et cetera. We roll these things up to these really big generalizable concepts that brilliant scientists work on. And then we tell them, we did this good thing for you, but their problems still exist in front of them. And so I think that there are really interesting opportunities to create new types of programs where you do really work with communities to co-create how to fund or match funding for actually solving problems at the community level in relationship between research and the people with the actual problems. I will just give a shout out. There's a small organization actually called Research Nova Scotia. It's the provincial science funder in Nova Scotia in Canada. They have a program called Focused Research Investments that literally was created to do this exact thing. And they just announced their first group of projects. And these researchers literally went into the communities where these problems are, with the people who have these actual problems. They worked with them to craft what's the question we're going to answer. And those users, those folks with the problems, will be part of the metrics and helping to determine whether this research was successful or not. And I think that's so novel that, yes, they still worried about merit. They still made sure the research was strong and it was solid and it was real quality research, that it was credible, that it was legitimate, valid, but they brought in this aspect of the community. Now, this goes with a paper that I actually just put out yesterday, which is this is not something we've done because it is very high touch. It requires people to not just roll up aggregate measures and say, my value is because I scaled something to 1 billion people. You have to understand that each community has value, and you have to believe that. And to me, this is an opportunity in a moment where a little bit more decentralization might be happening, is to really find ways for researchers to rethink the relationships they have with the communities that they sit within. Because I do think there's going to be a moment where we need research, but that doesn't mean we only need basic science, that we only need it in the form that it's always existed. We need it, but we need it in a relationship with avenues that allow people that have supported this work through their taxes for their whole lives to actually be able to glean real solutions from that investment. And I see that as a very exciting opportunity. And I think that if Vannevar Bush were here today, it would make him crazy to see that we were still using his prescriptions for a 1945 problem. He would say, do what I did, analyze your situation, find your new gap. Don't keep using a prescription to an old problem. And so I think we need to spend more time. And I invite other people to come up with other things they think the gaps might be. But I want us to start thinking more about the ecosystem that we have today and the reality of what we have today, not the 1945 or 1970s lens.
That's really interesting because, the kind of in the world that I'm in now with the Karen Toffler Charitable Trust and neurological diseases, there's a lot of rare diseases that maybe only 1 or 2 or 10 people in the world have, and there's no momentum or to fund that research because it's 10 people a year. However, there's this growing kind of patient advocacy where families are getting together with research and startups to really solve those problems. And a lot of times, some of the science may be already there, the understanding, the research. It's just bringing it to these patients that have no voice. But that's a huge cultural change. Do you think there's a swell that's happening? Because the momentum is on this 1940 structure.
So, so for years I've been talking about this topic, and there's not been a lot of momentum. I mean, I'll be honest with you, right? But what I will say is, I think that's why we're seeing a lot of what we're seeing today. You read about overhead rates and NIH in the news, or you read about stop work orders on all of the research grants until they evaluate them. Some of that, I think, is coming from the fact that they're not interested in potential impact. They're interested in impact. And that just means that we need to go back and look into kind of how we've done things. And there are some great stories that we can tell from real impact from the work that we've already funded. But I think the other thing we have to do is just be real with ourselves that it may not be a sufficient ecosystem to support the needs of today. It is necessary, but it may not be sufficient. And in my mind, I can imagine all kinds of interesting things that you could do, right? Like, for instance, around sort of rare neurological diseases. Okay, there's kind of an umbrella there that is a lot of different diseases, but maybe the equipment and the infrastructure has some overlap, right? So you could imagine patient advocacy groups getting together, funding one or two researchers just to focus on them, but they could have like a WeWork lab space where the infrastructure is sort of supported or funded through different mechanisms, right? I think that there are a lot of ways you can think about research getting done that aren't necessarily the ways we've always done it. But it does require that also funders have to stop being obsessed with scale. They have to actually become focused on, or even on research, right? They have to get focused on cures. They have to get focused on end goals. Like, what's the mission that we're actually trying to accomplish? Not papers, not the proxy measures of science. It's a little dangerous when you get a lot of proxy measures. It starts to feel like the end result, right? Well, we got a bunch of prizes and we got a bunch of papers and we had a couple of startups, so we succeeded. And it's like, but the problem still exists, right? So it's a little bit also about trying to morph the million ways that we could do this, and also just leave space for the fact that you can have more than one approach in a system. Right now, we seem to pit all different types of scientific funding or execution or performance against one another, right? It's like one has to be more important than the other. But the reality is, without application pathways, basic science doesn't help. Without basic science, your pipeline of ideas for the application space dries up. There is a symbiotic relationship, and yet they tend to fight with each other about who's more important, who's more intellectual, right, et cetera. I'd like for us to think about lots of different ways that we could perform mission-oriented research. And I think it's also a misnomer to say, oh, we need a moonshot back in the days when we loved basic science. It's like, what? We told people you have a really narrow goal. You're going to send a soft, squishy human in this can up into space through an atmosphere that wants to kill them, into a space that wants them to not be there, right? That will kill them in a billion ways, and then preferably bring them back alive. Like, that's crazy specific. Now, did a lot of great basic research get done? Yes. But it was mission-guided basic science. So did we get Teflon and Tang and Velcro? Yeah, we did, and it was great. But it wasn't because anybody was just not having a purpose. So I think it's important to wrap purpose around some things and to have some common purpose in spaces where people have critical mass of common purpose, even if it's not exactly the same research, and that purpose is really oriented in the ultimate end goal, not in these proxy measures along the way.
So, it's a very, it's a time, as you said, and I appreciate the kind of the sensitivity of what's kind of going on right today, the middle of February 2025. But, some would say that research, and I'm just thinking about the researchers that we deal with, they have that patient in mind. I mean, they've had people in their life that, have died of Alzheimer's or some sort of dementia or something, and they have that in mind, and that is their mission. But what you're describing is there's a disconnect. Can you expand a little? Because I don't think what you're saying is that they're only doing research to publish papers. I don't think that's what you're saying. So expand that.
Yeah. So but the organizations are grading them on these proxy measures, right? So the researchers I really want to cure multiple sclerosis. I don't know that that's one of the diseases you care about, but my mom had multiple sclerosis. So we'll talk about that. Right?
Of course you care about it.
So, and I believe this of all I know this of every researcher at the Department of Defense. They really they have this big vision in mind, right? But they have a job to do, and they do their job, and they do their job really well. They produce this good research. And then the way they're told that it's good is these proxy measures. Did you get it published in a good journal? Did it get cited, et cetera, et cetera? And then there's this feeling like my job is done. And what I'm saying is we are doing a disservice to the researchers by not proactively finding ways to ensure that all of this knowledge we are generating through public funds is being pulled into actual understanding, that we're thinking about mechanisms to push this all the way to solutions, that we're thinking about ways that we can actually create solutions for the public good, even when there's not an easily commercializable pathway, even when there's not a way to make someone rich by solving that problem. Even if you're making someone less rich by solving that problem. Because I'm pretty sure if I cured all sort of cardiovascular diseases tomorrow, the guys making statins wouldn't be super thrilled with the bottom line, right? I'm not saying they don't want to help people, but there's a lot of competing interests along the way. But there's kind of this gap in the system where researchers are doing exactly what we've asked them to do, and they're doing it really well. Some of the best in the world. And I love it and respect it. But again, it's necessary, but it's not sufficient to actually cure these people's diseases or clean the water. And when things don't easily make someone rich, we don't have mechanisms to turn them into solutions. And to me, this is just a real gap in the system that leaves people who really do care and who have done their part of the job, they've traversed their part of the journey. Either it leaves them moving on to the next problem because that's their job, or desperately fighting in the system to try to find ways to make it work, to get somebody to know about it, to figure out if some foundation will pay for it. And then what they hear from a foundation is, but how does it scale? How many people am I going to be able to say I saved? And so there's a real challenge with actually solving people's problems, not being inspired by them or creating the foundation for their problems to be solved, but to actually getting to the solution. And I just don't think we have very many mechanisms for that in the United States.
Yeah, that you once said to me, I love science, but I don't love the religion of science. Is this what you're talking about?
So it's partly it. I think part of what I mean when I say that is also that for me, science is a framework. It's a way of helping put a scaffolding around the ineffable universe, this incredible, complex universe that we cannot possibly understand. We don't even have a model of the human body. We don't even know how our bodies work. Physics isn't even correct, right? We'd have a unified field theory if quantum physics was right, and classical physics, those guys had to die before people believed in quantum physics. And now those guys will have to die before we believe in the next thing. And my frustration is just simply that, so it's kind of twofold. One is really that science is not about giving you the answer. It is not about giving you the capital T truth. It is about, I believe, how I was taught is that science is a place that you can go to try to accumulate more knowledge about things that no one has ever asked, questions no one's ever asked. Now, just because classical physics wasn't perfect doesn't mean it wasn't useful. It was super useful. And that's why we used it. But why did people get so religious about it? Why did they want to hold on to it so tightly at the expense of any other ideas being considered? And this, to me, is the religion that gets in there. Peer review is really difficult because of this. It's like, if I love what I do and I've dedicated my entire life to it and I believe that it is the one and true path, it is very hard for me to grade a proposal that suggests a new approach and to do that with an open mind and objectively. And so one thing I feel like part of science is supposed to be that we're open and that we know we're always learning and that we believe something today, but tomorrow we may get new information and we may have to change our minds. And that is what science is supposed to be. And somewhere along the way, we turned it into whatever we know today is capital T truth because science told us so. And if I don't fund the questions that make me uncomfortable, they'll never be true because I'll never prove it. And that is a dangerous road to go down, in my opinion. And so I just advocate for this approach to thinking about science with a much more open hand, much more as a framework for what we don't know as much as for what we do know. I also think that there is a religion around once you decide this thing is so important and I'm going to fight for it for my whole life, you're fighting against everybody else's priorities. And this, again, pitting these different parts of the ecosystem against each other makes it very hard to allow for a new sort of section to be created. It makes it very hard to fill that gap because no one wants to let go of any of their money or their power. No one wants to be criticized. They feel like if they're not doing everything, then it's a problem that they have to defend against rather than, yeah, I'm doing my part, but you guys really need to get somebody over here to do this other part because it's important. And we'd really love to work with them and hand off our ideas and figure out what a handoff looks like because these ideas are complex. They require expertise in the transition, et cetera, et cetera. And how are we going to fund that? And how are we going to think about all of the different places that students and postdocs might want to wind up, the type of work they might want to do, as opposed to kind of pitting people against one another and making it very difficult to create kind of these interstitial spaces in the system that are needed, I think.
Yeah, and I think we can go back. I think we should really go back in time in your career because you were a young scientist and a young researcher, and you wanted to change the world with your efforts. And there was probably some real pivot points where, you kind of question that your pathway there. Do you want to just kind of share on, because it's not like you're an outsider looking in and making these observations about what should be done, what shouldn't be done, what works, what doesn't work. I mean, you have real experience in lived experience.
Yeah, when I think back to that kid, right, I just think, oh, she was so optimistic, right? When I was in my 20s, I'm a pharmacist by my undergrad degree, actually, which I never really used. I mean, I did work in a pharmacy in school, but everyone, including the pharmacist I worked for, agreed I'd probably better go to grad school because my bedside manner was suspect. So I went to get my PhD in what we called pharmacognosy or natural products chemistry, which is sort of drugs from plants. And this was in the late 90s. Or the mid 90s. I was the first graduate student on a big new program at the time called the International Cooperative Biodiversity Group Programs. And they were through an international office at the National Institutes of Health. And what it was supposed to do in the 90s, interdisciplinarity was kind of a big deal. And in the 90s, universities and companies working together was unusual. So nowadays it seems really normal, but back then it was actually pretty uncomfortable for everybody. So I was at grad school working with a university here in the US. I was working with a large pharmaceutical company, and they were doing some bioassays for us. So I was doing the chemistry, they were doing the bioassays. And then I was working with a colleague in Chile where I was doing my plant collection. So I spent several months down there collecting plants, working with my advisor there who was a botanist. And then I came back to the US and I looked at the extracts and I did the biological assays, et cetera. And along the way, I had the opportunity to do some research on a plant that was being actively used. It was provided by a local tribe that had used this plant for for generations, right? For specific diseases or sort of how you present, right? I wouldn't call it really diseases that were similar to prostate cancer. So a husband of someone I was working with had prostate cancer. He was taking it and it was seemingly really helping. And everybody was a little bit confused and we're like, we should look into this. So we collected this along with the other plants we were collecting. And when we got back and we did the isolation, as a chemist, I was so excited. I got this big, beautiful crystal using X-ray crystallography. It was easy. I was so excited. We sent it off for the bioassay. It comes back with a very, very strong anti-tumor, like positive anti-tumor activity. I'm so excited that we've actually kind of supported that taking this isn't crazy, right? And I was told by the pharmaceutical company at the time that I couldn't use the bioassays. I couldn't publish any of that work because the compound was already known. It had been described in the 60s, and the biological activity had also been described. And so, even though the plant had not been looked at, and so it wasn't patentable. And in the 90s, we were still working out a lot of things. And so I was not allowed to publish it. And I was, as a young person, gutted that here we had this thing that was so clearly, concretely, and directly useful and was helping a patient in front of our eyes, and that we had kind of proven that it made sense and was being told that it just needed to be buried. So ultimately, we wrote up as much of it as we felt appropriate. I'm going to hedge my bets here on a podcast. And it was published in Spanish without my name on it because I felt a responsibility to it. But it was a real moment for me in realizing that the system wasn't necessarily going to value the things that I came into it to do. I wanted to cure tuberculosis. I wanted to run around the jungle like Sean Connery and Medicine Man and, cure the world. And it was disappointing and it was frustrating. And it was this realization that this was a bureaucracy and this was an ecosystem that I actually had to understand and to learn. So for me, and then with a couple of other things that happened, I decided that I'd be better off going into policy and going into the management of science than staying. I actually went to DC to work for the State Department in 2001, thinking I was going to work on sustainable development. And then 9/11 happened, and my whole life really became about security research. But where I really started was actually with the National Institutes of Health.
That's interesting. And because the plant is not patentable, then we couldn't really use it and get it out there.
And additionally, at the time, and I stand by this being largely true today, we're so rigid in the types of research we view as valid that it needs to be a purified compound, double-blind control, blah, 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 right? That you can never really research mixtures. And the reality is that with most plants, when you take an extract and you have hundreds of compounds in it and you do the bioassays, that activity is coming from lots of different compounds, right? The aggregate activity. So what we do in science is pretty reductionist. We pull out the most active one and we just focus on that. But the reality is that there's so much value that can come from that complex mixture that we lose. And so the science, we just haven't, again, it's a question we're unwilling to ask. Because our processes don't support research on it, we don't do research on it. Because we don't do research on it, it's viewed as a less valid approach to healthcare, even though it's the most accessible form of healthcare globally.
Yeah. I want to go back to what you said about how the other countries are really starting to kind of, I think you use the term punch over their weight when it comes to science and innovation and such, and that it's a very kind of regional area. And I know some work a long time ago that you were trying to do was really trying to anticipate where innovation would happen globally because of this regional geographic area. Can you kind of expand on why do certain countries become leaders in certain things? And what does that mean to the US when, we're looking at maybe partnerships or trying to really bring solutions to the American public?
Yeah, it's interesting. It's hard. So I'm going to start with the first part, which I think is easier. Like, alliances are complicated and they're more complicated today than they were a year ago. So we can talk about that. But I do think that a lot of countries, take like Korea, for example, right? And they're an amazing research and development powerhouse. In fact, like historically, over the last 20 years, I'd say that if you looked at two countries, it was South Korea and Israel that would bounce back and forth between the countries that invested the highest percentage of their GDP into R&D. So Korea has always viewed this as they've been over 3%, and they've always viewed it as incredibly important. They're also, I think, just a very tech accepting country generally. But the things that they're amazing at are things that they have strong industry in, right? They're incredible at shipbuilding. They're incredible in electronics, and they're incredible at a lot of that research that sort of underpins those pipelines of materials and compute. You look at a country like, say, the UK or trying to think, there was another country. Anyway, shortly after the US stopped doing stem cell, we did a moratorium on stem cell research, I don't know, decades ago now. And when that happened, the UK and one other country, it may have been Korea as well, literally came out, or maybe it was Singapore, said, we're now prioritizing bio because it gave them breathing room from that head-to-head competition. And there was like a little niche that was opened up where they could really excel. And they've done really well in the biomedical space. And that really, I think, started from a very strong decision across the board that they were going to focus on that and they were going to pour some support into that. So I think a lot of countries are trying to figure out where can they create a foundation of sort of intellect and skill and talent that both provides them research leadership, but also supports their sort of economic capability to sort of derive benefit from those areas.
So, Melissa, you've been very outspoken with, kind of the dynamics, if you would, of being a researcher. And I've heard it from some of our researchers too, is that, by the time they have a lab and they're able to pull in grants, they're in their 40s. Like they've put their life on hold as far as marriage and kids, and because they haven't been paid enough to, and it's amazing that they even stick this out, and you've been very vocal on like pay them, like pay them to get higher quality research. Like, if we want to solve the STEM problem, pay them.
I do feel very strongly about this. I feel like somewhere along the way, the United States research funding community decided that we were going to be more like Walmart, that volume was better at any cost. And so the less people cost, the more volume I can get out of them, right? Return on investment. I want as many publications and proxy measures produced for as little money as possible. And I find that to be, quite frankly, disgusting. I also don't find it to be a great recipe for quality. And I think if you want people who are truly high quality and who are really going to be willing to answer a person in the community's call, even if they're not getting paid to do it, you've got to give them a lifestyle that reflects that they have some breathing space, right? I think every grad student, postdoc, I think I look at grad students like student athletes, right? They are making you money. They are the ones producing most of the work. The grad students and the postdocs are managing most of the grad students, right? That all of these people need health insurance. Every time I hear somebody say, well, Americans won't do this. Well, no, they won't, because they won't get health insurance. They won't get paid any amount of money that will let them like live without roommates. They can't get married and have kids. God forbid, if you're a woman and you have a kid and you're out of commission for 2 years, you may never get another job. If you want high quality work, you should pay for the quality you want. And if you want Americans to do these jobs, then you need to pay them like you would pay anyone else. I mean, they deserve to be treated like professionals. And this obsession with quantity really annoys me, because I don't think that doing less research gives you less knowledge. I think you need to pay for the quality of work that you want to receive.
Yeah, I think I think a lot of people that maybe they don't know somebody in the area of research, or they just haven't really looked at it, would be really kind of surprised at how little these people are making with how much that they do. And many of them, like some of the researchers that we deal with, they have patients. So they see patients all day, and then they go into the lab, and then they do their lab research. And, I don't know how when I
Yeah,
ask
these people
them,
are sleeping in their offices, right?
you ask them, what was the last book you read? And you're like, a book? I don't know. Like, for what? For pleasure? Never. So not since a long time ago. So yeah, I think that is really important. And it's an important part of the discussion, I think, especially today, right? Especially in today's environment, as we're maybe there's a door opening to look at some of these different models that you're kind of talking about.
I think that we're in a moment of there's a lot of change happening. Some would call it chaos. Some would not, but I think if you're a scientist right now, it feels pretty chaotic. And I would never want any of my comments to feel anything other than respectful, because this is my community. I do love science. I love it so much that I want it to be better. I want it to evolve, right? And I want to be a part of that. But the people doing this work are not the problem, right? The people doing this work are doing it under incredible strain and an incredible number of demands, and this endless need to find money all the time to keep your lab going. I will say, when you go back to maybe historically a more sort of quote unquote normal sort of baseline for the United States, and you look at the US before World War I, there's a guy actually, Hunter Dupre. He wrote a history book about science in the federal government, and he looked at science in the United States from 1776 all the way up to like 1940. And it was it's not like the best book you'll ever read, right? I mean, don't get that excited about it. But it was fascinating to me, because I nerd out on this stuff, to see like how a lot of the structures that exist in science actually were created over time. And there were a lot of moments where we had a lot of places where people supported science being done and supported private laboratories where scientists could get work done. And they didn't just support them for a year and then expect them to find money somewhere else, right? They really had patrons, right? And I think that while I don't want to go back to that world, I think we can revisit a lot of ways that we used to do science and then try to envision new ways that the information age has brought to us and start to think about what that basket of sort of different approaches could look like if we were thinking about it in a new way. If we were thinking about some of the gaps that currently exist, some of the challenges we have for supporting research, trying to get researchers to stop focusing so much on grants, on getting the next dollar, and instead really focusing on the work, trying to create transition paths for the public good to get real solutions out of these, which may be funding people with a different skill set to work alongside those researchers and to harvest as they go, but to have those relationships and deep knowledge in those areas. I don't know. There are probably a million ways we could brainstorm to do this. Maybe not a million, but more than what I can think of. And more than we currently do today. And I do feel like, as chaotic as things are, generally, along with the bad, once things are sort of reset, usually there's an opportunity for some good to come out of it too. And I'm hopeful that if we can think now, if we can support some people to really think about the changes that are, or there's not even just changes, but the additions, what that ecosystem basket needs to look like in order to solve the problems we have today, we might be ready to take advantage of that if there's an opportunity on the other side of some of the chaos.
So what's the one thing then that you would want us to start doing right now to do that, or stop doing to allow for that to happen?
I would love to see philanthropy actually fund a series of conversations at towns, states, regions, different kind of levels of granularity around different topics to say, how would you feel about actually working with researchers to solve problems, right? How would you think about funding that? What's the basket of funding that you can imagine? Could we get industry involved in this? I think crowdsourcing money is also completely reasonable, right? I'm surprised more scientists don't just crowdsource funding their own work, honestly. I think I'd just go on Kickstarter if I was a scientist at this point. I mean, it's easier. I would also like, I think, for us to do a really hard look at this is going to seem like it's a little far afield from science, okay? But bear with me. I think coming out of the post-World War II era, that era is sort of winding to an end and we're in a transition to something else. And it's very emotional for people and it's very difficult to live through a transition. But we're coming out of an era where it has been viewed as fact rather than an assumption that economic growth is good for everyone. And I think if you actually do the analysis that it was true for a while and then it became less true, and now you can probably say that growth is really good for the very poorest and the very richest, but the people in the middle sort of rose and then they fell. And there's probably another basket metric that we could think about, much like we have a basket of things that we put in order to assess inflation, right? Is there sort of a basket of things that we can put in to assess the health of a country, right? If you want a country to last forever, you've got, or a very long time, you got to think of it just like, I don't know, occasionally I hear these guys who are like, I'm going to live forever, right? And they're talking about everything they've done to optimize their bodies and all the research they're doing on the microbiome to help them think it through. And we don't think it's crazy when a person wants to change their lifestyle to improve their longevity. But we don't actually think about the nation that way. And I think it would really help researchers be able to sort of slot themselves into a slightly different position in society if we were viewing the kind of ultimate end goal as a thriving nation, and we had a proxy measure for that was something other than GDP, because that may allow us to create mechanisms that funnel solutions into the public good space and have that account for something in the measures. Does that make sense?
It does. And it takes me back to, kind of the beginning of the conversation, which the conversations have to start to, happen very regionally at the town, at the community, because, there is such a difference across our country as to what that is. And there might be some roll up for sure, but it really has to happen and to share that information from community to community.
And also, I think defining community, like you really brought this to light right in this conversation, which is like you have these patient advocate groups. That's a community. They may not be geographically co-located, but that is the community, right? And so the community conversations don't just have to be happening in this kind of nostalgic view of community. It's definitely one way, right? It's definitely a useful and necessary way. But there are a lot of other versions of community that I think are really powerful to bring in. Because I guarantee you there are patient advocate groups that if you really said, this researcher has something, no company is going to touch it because it won't make any money, but we could solve this problem, they would probably help you raise the money to just go solve it. And sometimes you just have to empower people to solve their own problems. And you have to get the scientists to a place where they know they're not sacrificing their own prestige, they're not sacrificing their own career in order to do this. And shame on us for giving them that choice.
Yeah, well, that's another whole conversation about the power of the internet and social media and the ability to do good, because there's a lot of communities on these things. Some of them are for good. A lot of them are for, I don't know, other things. But, that is a real kind of discussion that, we should be having with these other communities. So, Melissa, as we wrap up here, what do you hope for the future? I mean, you're pouring your time, your energy, your whole career has been pretty much, in one way or another, a part of this perspective. What's your hope for the future?
I want science to be an attractive career, right? I want it to be a place where people can ask uncomfortable questions. I want it to be a place where we can plumb the absolute depths, the very edges of what we know about the universe. And I want it to be a place that really loves the community that it is there to serve and is paid in a way, and not just money, but through time and the types of jobs that are offloaded, like the constant need to seek grants and some health insurance and things like this, right? It's not just about the money. It's about the sort of what that career looks like. I would like for that career to be attractive so that those people are inclined and are rewarded for opening their door when the community wants to engage, and opening their door when someone says, I can make this a solution if you work with me, if you give me the time and the space to learn enough, and you answer my questions as we're encountering problems in actually implementing it, right? Right now, there's no time left in the day for all of these optional activities. And I want it to be a career that attracts creativity, supports creativity through a lifetime, but also instills a sense of responsibility to the community and really proactively engages in ways to make sure that their work is ultimately useful, not just potentially useful.
So if there's like-minded people out there that want to join the conversation, how do they get in contact with you?
You can reach me a lot of ways. LinkedIn is a good way. You can reach, I actually sadly went off a bunch of social media recently because I was getting a little too riled up. So I have a website. It's Flagg, my last name, FALGG consulting.com, and you can reach me there. You could also put my email, quite frankly, in the show notes. I am very open. I love to engage people. I was taught in my first job in the government by a boss that I spent a lot of time being paid by the taxpayers. And I believe that everyone gets an hour. I'm not promising you a second hour, but if you want to talk to me, I will talk to you because I feel a responsibility to do that. And I do not want to be someone who pulls the ladder up behind me. A lot of people helped me through my career, and I want to be a part of the solution.
That's great. As always, Melissa, I've known you for a while, a long time. Wouldn't say how much, but I really appreciate your time. I always come away from these conversations just, just energized and thinking, about things and in a different way. So I really appreciate your time and thank you very much.
Thank you so much. I think your community is incredible, and I really appreciate you letting me be here.
Thank you for joining Research Renaissance. For more information and to stay updated, subscribe for more episodes and visit our website at tofflertrust.org. Feel free to call us if you have any thoughts, suggestions, or just want to find out more about the Karen Toffler Charitable Trust. Until we meet again, onward and upward.